So this is the half-past paper for week 7. We are back to the non-calculator paper. So this is a non-calculator paper. All of the odd numbers, 40 marks instead of 80, should take you roughly 45 minutes if you're thinking about exam timings. And as usual, all the Sparks codes are on the end for you. If you do have access to Sparks, you can always look at further practice by typing that code into independent learning on that app. Okay, great. Question number 1. There are only blue cubes, red cubes and yellow cubes in a box. The table shows the probability of taking at random a blue cube from the box. The number of red is the same as the number of yellow, so we know the probability of these two sections are equal. Complete the table. Okay, so probability always adds up to 1. I've got 0.2 so far. If I do 1, take away 0.2, I'm left with 0.8, and I know that the number of red cubes and yellow cubes is the same, and therefore the probability is going to be the same, so I can just divide by 2, and that is 0.4. So 0.4 is the probability of red, and 0.4 is the probability of yellow. There are 12 blue cubes in the box. Work out the total number of cubes in the box. So 0.2 is equivalent to 20%. So I could just say 0.2, which is 20%, equals 12. That might help people a little bit more. So 12 cubes. If I then want to know how many cubes there are altogether, I'm looking for 100%. I want all of the cubes in the box, or 1. Okay, and that would be multiplying by 5, so that would be 60. That's one way of doing it. The other way of doing it would be to say, well, if I know that this is 12 cubes and that has a probability of 0.2, a probability of 0.4 would be double as many cubes. So that would be 24 cubes, that would be 24 cubes. And if you add all of those together, 12 add 24, add 24, that is also 60. So a couple of different ways you could do that one, but 60 is your answer for 2 marks, however you did it. Question number 3, find the highest common factor of 72 and 90. Now we could list all of the factors, all of the numbers that go into 72 and go into 90, and look for the biggest one that they have in common. But because sometimes we have to do this as prime factorisation, I'm going to practice that method just to revise it. So 72 is 2 times 36. You could do 8 times 9 or anything you like, but if you get to a prime number, you're going to circle it. You'd get the same answer no matter what. 36, I'm going to do 6 times 6. Neither of those are prime. So 6 is then 2 times 3, and the other 6 is also 2 times 3. So 72 is 2 times 2 times 2 times 3 times 3, or 2 cubed times 3 squared. For 90, I'm going to do 9 times 10, 3 times 3, and 10 is 2 times 5. There we go. So 90 is 2 times 3 times 3 times 5. Fabulous. So looking at both of those, I'm then going to do a Venn diagram. And if you want the highest common factor, we're just going to multiply together what ends up going in the intersection, in the middle bit of the Venn diagram. Now, what can I put in the middle? I can put a 2 in the middle because they both have one of those. I can put a 3 in the middle because they both have one of those. I can put another 3 in the middle because they both have another 3. Now there's nothing else in common. With 90 I've got 5 left to go on the outside, and with 72 I've got a 2 and a 2 left here. Your highest common factor is all the numbers in the middle multiplied together. So 2 times 3 times 3 is 6 times 3, so 18. If you wanted the lowest common multiple, the first number in the 72 and the 90 times table, you would take that 18 and multiply it by any numbers left on the outside. So I'm going to times by 2, which is 36, and then times that by 2 and times it by 5. So I've got 2 and 2 and 5, 2 and 2 and 5. Those are the numbers left on the outside. I know that 2 times 5 is 10, so that's probably going to be the easiest way to do it. 360 is your lowest common multiple. So if they'd asked you for the lowest common multiple, you'd have to times all the numbers in the Venn diagram together. In this question, they just wanted the highest common factor, so it's just the numbers in the middle of the Venn diagram, and that is 18 multiplied together. Wonderful, 2 marks for that one. Question number 5, and we have some transformations. It says shape A can be transformed to shape B. Now, transformed is the name of all of them. Remember that transformations, you've got rotation, you've got reflection, you've got translation, and you've got enlargement. Don't confuse transformations with one of those. It is the name of all of them. So we've got rotation, reflection, translation, and enlargement. Shape A can be transformed, so by one of those, to shape B by reflection. So reflection is the transformation that we're looking at here in the x-axis, followed by a translation CD. Okay, so first we're going to reflect A in the x-axis. This line here is your x-axis, but remember, if you wanted the line x equals 1, it's the line that goes through 1 on the x-axis and it goes the other way. But for this question, we're just looking at the x-axis. Your 2 squares up, so we're going to reflect 2 squares down, and your triangle is 3 tall, 2 wide, and goes there like that. So that's shape B. Shape A can be transformed to shape B by a reflection in the shape... Oh, that's not shape B. That is almost shape B. We've got to translate it now as well. So we've reflected it, and now we've got to do a translation. Now, translation is when it's just moved. Your top number in this vector is how much it moves left and right. Negative is left, positive is right. And the bottom number in the vector is how much it moves up or down. Positive is up, negative is down. So we want to move it. I'm just going to pick a point. Doesn't matter which point you pick, but you need to go to the same point on the other shape. We need to move it 1, 2, 3, 4, 5, 6 to the left and down 1. So left, we're going to use a negative number, and down, we're also going to use a negative number. So this is going to be minus 6, minus 1. We never put a line. It's not a fraction, okay? Never put a line, just top number, bottom number. Minus 6 is the value of C, and minus 1 is the value of D. Question number 7. Here are 2 rectangles. Q to R is 10. I like to draw it on. As soon as I know what something is, draw it on because it might help you. And it says that BC is equal to PQ. Now, I don't know how long that is, but I'm just going to call it X. I'm going to say this is X and also this is X. B to C is the same as P to Q. So I'm going to call them both X so I know that they're the same. The perimeter of ABCD is 26. So this shape has a perimeter of 26 centimetres. And this shape, the area of PQRS, is 45. Find the length of AB. So I don't have enough information in this triangle to get that perimeter being 26. I don't know anything yet. But in the triangle on the right, I know that if the area is 45, it must be x times 10, because area is base times height, to get 45. So therefore 10 times x, or 10x, equals 45. Dividing both sides by 10, we can see that x is 4.5. There we go. So x is 4.5, and I'm going to pop that up there. And if I know that x is 4.5, then I also know that this one is 4.5 because we were told in the question that they are the same. Great. This is a rectangle, so this one must also be 4.5. And then let's call this y because this is what we're trying to work out. We've got to find out the length of AB. I now know that 4.5 add 4.5 add y equals 26. The distance all the way around the outside of his shape, that's the perimeter, is 26. So 4.5 add 4.5 is 9. 9 add 2y is 26. Taking 9 away from both sides, 2y is 17. And then dividing that by 2, 17 divided by 2, well 16 divided by 2 is 8. 17 divided by 2 is 8.5 centimetres. So that is your length of AB, 8.5 centimetres. Work out 3.5 times 1 3/5. Give your answer as a mixed number in its simplest form. So this is a non-calculator paper and a really, really common question for the non-calculator. Either we're going to be asked to add, subtract, multiply, or divide fractions. So here we're multiplying. We're going to start by making both fractions top heavy. So to do that, we multiply the big number by the bottom and then add on the top. Okay, so 3 times 2 is 6. Add the 1 is 7 over 2. And then same with the next one. 1 times 5 is 5. Add the 3 is 8/5. Good, and we're multiplying those together. Now, when we multiply fractions, we do not need to make the denominators the same. You only need to make the denominators the same for adding and subtracting fractions. So when we're timesing, this is one of the nicest things we could be asked to do. 7 times 8 is 56, and 2 times 5 is 10. How many 10s go into 56? Well, that fits in 5 whole times, with 6 left over out of 10. However, we would lose a mark for this because we've been asked to give it in its simplest form. And that fraction, 6/10, can be simplified to 3/5. So we're going to leave our final answer as 5 3/5 for 3 marks. Question number 11. A bus company recorded the ages and years of the people on coach A and the people on coach B. Here are the ages of the 23 people on coach A. Complete the table below to show the information about the ages of the people on coach A. So luckily for us, they're already in order, which is great because we need to work out the median, the lower quartile, and the upper quartile. So the median is the middle value. If you have 23 pieces of data, you are always going to add 1 and divide by 2. We add 1 and divide by 2 to get the position of the median. So that would be 24 divided by 2 is 12. So the 12th piece of data is your middle. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that makes sense. We've got 11 pieces of data below and 11 pieces of data above. So the median is 59. The lower quartile, that needs to be a quarter of the way through the data. So you've got now 11 pieces of data below and 11 pieces of data above, and we need to go in the middle of that. So 11, add 1, divided by 2 is 12 divided by 2, which is going to be the 6th. So 1, 2, 3, 4, 5, 6 is 53. That's our lower quartile, and we're going to do exactly the same above to get the upper quartile. So again, there's 11 above. It's going to be the 6th of those 6. That is your upper quartile. So 66 is the upper quartile. That's 25% of the way through the data, 50% of the way through the data, and 75% of the way through the data. Richard says that people on coach A are younger than people on coach B. Is Richard correct? So this is coach A, this data here, and this is coach B, this data here, and he's asking whether they are younger. So for that, the best measure of that is going to be to look at the median. So we can see the median for coach B is 70. So on average, the age of the people on coach B is 70, and on average, the median of coach A is 59. So we would say yes, the median for A is lower. The median for coach A is lower. So on average, the people on coach A are younger than coach B. And I'm just going to put the data there as well. 59 is less than 70. There are some other things that you could look at. You could say, well, the least age of coach B is 42 and the least age is 41. So there is a younger person on coach A, but we want to take all of the data into consideration. So I think this would be the best answer here. Okay, part C. Richard says that people on coach A vary more in age. Now, when we're looking at varying, we're looking at the spread. You can either look at the range, which is the highest, take away the lowest, or you can look at the interquartile range, which is the upper quartile, take away the lower quartile. So let's have a look at both of those. The range for coach A is 79, take away 41, which is 38. And the range for coach B is 85, take away 42, which is 43. So we would say the range, coach B, is varying more because the range is bigger. Let's just check the quartiles as well. So if I wanted the interquartile range, the difference between the upper quartile and the lower quartile, 73 take away 54. So 13 take 4, that's going to be 9. 6 take 4 is 1. So I've got 19 there. And same with coach A, 66 take away 53, upper quartile take away lower quartile is 13. So again, that's smaller. So it doesn't matter which one you use here. You can use the interquartile ranges, or you can use the ranges, and we're going to get the same answer either way. The coach B is a bigger number in both cases, so that's going to be more varied in age. What did Richard say? He says the people in coach A vary more in range. So is Richard correct? No. Both the interquartile range and range, you don't need to work out both, one is sufficient. Both the interquartile range and range for the people on coach B are greater, therefore more varied. Brilliant. Question number 13. Given that n can be any integer just means whole number, such that n is greater than 1, prove that n squared minus n is never an odd number. So with this question, what a lot of people do is they say, I'm going to try 5 squared, take away 5, and 10 squared, take away 10, and 3 squared, take away 3, and just try it for lots of numbers. Now, you could try it with a million numbers, and you're still never going to prove it. We need to prove it with the algebra. And if we can prove it with n, we know it will always work no matter what. So I've got n squared minus n. I'm trying to show that when I square a number and I take away the number itself, it will always be odd. That's really hard to prove looking at it like that. What else could I do with this expression? Well, I could factorise it. So both of these terms have an n in common. I could take n outside and make it n minus 1. And now look how this changes. This is now a number multiplied by the number 1 less than that number. So for example, if n was 10, we would then be timesing it by 9, because n minus 1 would be 9. If n was 8, we'd be timesing it by 7. If n was 100, we'd be timesing it by 99. What is always going to happen there is because you're always going for the number that is 1 less. If this number is even, then this number will be odd. And if this number was odd, then this number would be even because it's 1 less. And even times odd is always even. So if you have an even number and you times it by an odd number, you will always get an even answer. Therefore, never odd. And that's all we need to say for 2 marks. Question number 15. The diagram shows a solid shape. The shape is a cone on top of a hemisphere being half a sphere. The height of the cone is 10. The base of the cone has a diameter of 6, and the hemisphere has a diameter of 6. The total volume of the shape is k pi, so just something pi, where k is a whole number. What is the value of k? So we've got to work out the volume here. So I'm going to do this in 2 parts. I'm going to work out the volume of the cone, and I'm going to work out the volume of the hemisphere, and then I'm just going to add those 2 answers together. So the volume of a cone, we're given the formula here, is 1/3 times pi times the radius squared. Well, the radius is going to be from the middle of the cone to the edge, so that's 3. So 3 squared times 10. So 1/3 times pi times 9 times 10, so times 90, and 1/3 of 90 is 30. So this is just going to be 30 pi for the volume of the cone. For your hemisphere, now there's a couple of ways you can do this. The volume of a whole sphere is this. If you want a hemisphere, you can just do 2/3 pi r cubed. However, you can also do 4/3 pi r cubed and just half it if that makes more sense to you. But equally, a little bit quicker to do 2/3 pi r cubed. So I'm going to do that here. 2/3 is half of 4/3, so you end up with half as much. So 2/3 times pi times the radius cubed. Now the radius we've just said is 3, so that is 27. So I've got 2/3 times pi times 27, and I'm just going to do 2/3 of 27. So divide by the bottom, which is 9, times by the top, which take that 9, times it by 2 is 18. So I've got 18 pi here. 18 pi for the hemisphere, 30 pi for the cone, so altogether 48 pi. So k is just 48. Work out the value of k, pop that down there, 48. 4 marks for that. It's quite a nice, straightforward one. I was looking at that thinking, is that all we have to do? Okay, great. Love it. Right, question number 17. Given that x squared to 3x add 5 is in the ratio 1 to 2, find the possible values of x. Okay, so if it's in the ratio 1 to 2, 1 to 2, this side is worth double this side. So it might make sense to you to just say, okay, to make this an equation, I just need to double this side. So 2x squared would be equal in value to 3x add 5. If this side is 3x add 5 and this side is x squared, I just need to double that side. So that's one way of thinking about it. However, another way that you can think about it is like this. If I was to tell you that the ratio 3 to 5 was equal to the ratio 6 to something, you guys would probably be able to tell me that that question mark needs to be a 10. Why is that? The reason why is because you know that 3 to 6 has been times by 2. And so if this ratio is equivalent, the 5 also needs to be times by 2. So what we can do is say this divided by this is equal to this divided by this. And you might find that that makes more sense to you. So in that case, how would we write that? We would say 2 divided by 3x add 5 equals 1 divided by x squared. The other way up would work as well. And then because I've got fractions on both sides, I can multiply this up to here and multiply this up to here. So I still am going to get the exact same thing, 2x squared equals 3x add 5. Okay, so it doesn't really matter how it makes sense to you, but that's what we want to end up with. Now this is a quadratic, and so to solve it, we want to make it equal 0. I'm going to try and keep this term positive. So I'm going to take 3x away from both sides, and I'm going to take 5 away from both sides. That leaves me with 2x squared minus 3x minus 5 equals 0. Now we're on a non-calculator paper, so I'm assuming that we're going to be able to factorise this. Let's have a go. If not, it would have to say give your answers in surd form or something like that. So I'm hoping it's going to factorise. 2x and x, I know it has to be 5 and 1. That's the only digits that can times to make 5 on that end. So if I put the 5 here and the 1 here, I get 10x and 1x, which is never going to be able to add to make minus 3. So that's no good. Let's turn them around the other way and pop the 5 here and the 1 here. Then we get 2x and 5x. I'm happier with that. I can make that make minus 3. If it's minus 5x, add 2x. There we go. So now we factorised it. We just need to solve when each bracket will equal 0. So what value of x makes x add 1 equal 0? It's when x equals minus 1. And how does 2x minus 5 equal 0? So if I start with 2x minus 5 equals 0, 2x would need to equal 5 and x would equal 5 over 2 or 2.5, however you want to write it. There we go, find the possible values of x. So I'm going to say x equals minus 1 or x equals 5 over 2 or 2.5, however you want to write it. Question number 19. Given that x squared minus 6x add 1 is x minus a all squared take away b for all values of x, find the value of a and the value of b. So this topic is called completing the square. You may not have done this yet at school, so I'll give you a quick crash course. When we write a quadratic in this form, it's called completing the square. Now to do that, we're always going to halve this number. So I'm going to start by writing x minus 3 all squared. Now the reason we're halving it, if I multiply that out, x minus 3 squared means x minus 3 times x minus 3. So that's going to be x squared minus 3x minus another 3x add 9. So because it's minus 3x, I end up with minus 6x, which is what I wanted. But I did not want that extra plus 9. That's a little bit annoying. I don't want that bit. I just want this bit. So always we half that number and then we take away whatever this number is squared. So take away 9. And that's going to leave you with the x squared minus 6x that you wanted. And then you can just bring down the plus 1 and that will get you x squared minus 6x add 1. So I'm going to sort that out. It's x minus 3 all squared minus 8, because if I've got minus 9 and I add 1, I'd get minus 8. Therefore, a, now look, in your equation up here, they've already put a minus in it. So A is just 3, and again they've already put a minus here, so B is just 8. Hence, write down the coordinates of the turning point. So the turning point is found by whatever value makes that bracket equal 0. Whatever value of x makes that bracket equal 0. So in this case, that's going to be 3. And then whatever number is here is your y coordinate, which is minus 8. So the opposite of the value in the bracket, whatever makes the bracket equal 0, and then the other value is just as it is. That is the turning point. So this quadratic comes down, goes back up. That turning point there is 3 minus 8 on a graph. Okay, quite tricky that. Question number 21. The functions f and g are such that f of x equals 3x minus 1 and g of x equals x squared add 4. Find f to the minus 1 of x. So f to the minus 1 of x means the inverse function. What does f of x do? Well, f of x, it takes the value x, it multiplies it by 3, and then it takes away 1, and that gets you the output. When we're asked to find f to the minus 1 of x, the inverse function, it's asking you, how do I get from this output back to x? And to do that, we would want to add 1, and then we would want to divide by 3. So how am I going to write that? I'm going to write x, add 1, all divided by 3. And that would take any output, reverse all of those steps in reverse order, and get you back to the value that you put in. Then it says, given that f of g of x equals 2g of f of x, show that 15x squared minus 12x minus 1 equals 0. So they are asking you, when they say show that, they're saying, can you please come up with this as well, using this information? F of g of x is a composite function. We're going to put x into g, and then we're going to take that answer and put that as the input into f. So I'm just looking at f of g of x first. Now if I put x into g, I get x squared add 4. Lovely. So putting x into g gets me x squared add 4. I now need to take that x squared add 4 and put that into f. So this is 3 lots of x squared add 4, take away 1. I'm using this as my input and I'm putting it in here. So I'm timesing it by 3 and taking away 1. Okay, so timesing that out is 3x squared add 12 minus 1. So that's 3x squared add 11. Lovely. I've now got to do g of f of x. I'll worry about the 2 afterwards. I'll double it afterwards. But g of f of x means putting x into f and then taking that answer and putting it into g. So let's do g of f of x. I'm going to put x into f first, and we know that that gets us 3x minus 1. And I'm then going to take that 3x minus 1 and put it into g. So that means I'm going to square it and then add 4. Now squaring a bracket means timesing it by itself, so we need to do 3x minus 1 times 3x minus 1 and then add the 4. So that's 9x squared minus 3x minus 3x, add 1, add 4, because minus 1 times minus 1 is add 1. Okay, great. So g of f of x is 9x squared minus 6x add 5. From the 1 add the 4. And I didn't just want g of f of x, they actually asked me for 2 of those. So I'm going to double that. So 2g of f of x equals 18x squared minus 12x add 10. This is very much a grade 9 question, by the way, so if you are managing to follow along, well done. So now I've got to make them equal. It says f of g of x needs to equal 2g of f of x. So I've got 3x squared add 11 equals 18x squared minus 12x add 10, but they've got it equaling 0. It's going to be easier to keep this term positive. We can see they've got 15x squared, so I'm going to take 3x squared away from both sides, and I'm also going to take 11 away from both sides. So 0 equals 15x squared minus 12x minus 1, and that's exactly what they gave me. That's what they said we needed to get. We don't need to solve the quadratic. They've not asked us to do that. So that is what they asked me for. Show that that is 0, and we've done that. That was the last question on the paper. Very, very challenging. Definitely grade 9 for that one. So well done if you followed along, and if you didn't, please don't worry, that is exceptionally challenging for the GCSE Maths paper. That was 40 marks. I hope you enjoyed it. Let me know in the comments if you've got any questions, and I will see you guys next week.